Is rolling. Hi, today is May 24th, 2006. I'm Jim Lumsden, manager of the System Safety Program Office, and today we're here to interview Larry Montgomery, known as Monty by everyone that knows him. Monty actually started the System Safety Office at JPL, and today we're going to chat with Monty about some of his experiences in developing the system safety program at JPL. Monty, you worked at JPL for many years. What years were they? What did they span? And did you work anyplace else before JPL?
I worked 3.5 years for the Arnold Engineering Development Center in Tullahoma, Tennessee, which was my first job out of school. And then in 1955, October the 3rd, I went to work for JPL. At that time, I had been doing rocket motor work, and they wanted me to come to JPL to do the Sergeant rocket testing.
That's going back quite a ways.
That's going back quite a ways.
When did you know that you wanted to be an engineer?
Oh, I was an engineer from the time I was 5 or 6 years old. I built little things. I built a better mousetrap. The only problem was it squished them. and too much cleanup was required. So
okay.
my
That's
mom
the
made
downside.
me quit that. I'd always heard a better mousetrap would be good.
So you always had it in mind to be an engineer.
That's true.
What schools did you attend, and what degree did you obtain?
I graduated from high school in San Angelo, Texas. Went to the University of Texas in Austin, which was the only University of Texas at that time. And I graduated from there in 1952 with a degree in mechanical engineering. I had been studying aeronautical engineering before that, but I decided mechanical was a wider area, so that's the reason I chose that at last.
So you got into rocket testing at Arnold Engineering, and how was it that you came to JPL? Did they come seeking you out, or?
No, not exactly. What happened was I got very disappointed in Tullahoma because there was a job I thought I was fit for, and they hired someone else in that job. Made me a little unhappy, and I started looking for a job. I decided I would move from there. Turned out that I saw a very small article in the Aviation Week which said engineers apply to JPL. And I called up, and they said, oh, we got a guy coming out there to interview who happened to be Jim Burke. And I met him in Chattanooga, Tennessee for the interview. We went Table Mountain and having a great meal up there, and he was watching the stars and all that kind of good thing. And it seemed like to me he didn't ask too many questions of me, so I thought, well, if that's the way he wants it, that's the way it is. Anyway, bottom line was he came back and told Chuck Cole that he could hire me. So that's how I got to JPL, and I called up Cole and asked him what he's going to offer, and we were happy, both happy with that, and here I am. I really wanted to go to school, actually, and the reason I came to Caltech is so I could go to Caltech. When I got here, I found out they wouldn't take part-time students. So since my wife and I had a little boy, I didn't get to go to school.
Had to pay the rent.
I had to pay the rent. I went to UCLA and USC, both, at different times.
All right. You said you came out here and started working on the Sergeant program. Could you give us some more details on that? What were you doing on the Sergeant?
Well, the Sergeant was just being developed, and they helped design the motor case, which they thought could not be as light as we had designed it. And we found one person in the United States, which was up in Schenectady, New York. And he said that he would try it, but all the other people were skeptical of trying to make a motor as thin and lightweight as we had asked for. So we designed it, went up there, had them made, tested them, and it worked perfectly.
Now, was that a metal case, or was
It was a metal case. It was 3340 stainless, and it was welded case, and They were worried about the welds, that type of thing, mechanically, because actually in one case we had it offset 100% when the weld was made mechanically. And as a result of that, they were very concerned about it. We put one, of which your picture shows in there, into a test area and blew it up. And as a result of that, we could determine that it held a lot more pressure than was ever expected to hold in the first place from the design. So this offset didn't hurt anything at all, but it did to give us a real recognition of the hydrostatic testing, because of the fact we poured water into it, I should say water testing, and got it filled up, and supposedly the water's not going to compress, but we kept putting pressure on it until it did blow, and we found out that the water pressure and expansion was so great it bent the things we had it attached to and broke the cables which we had pulled down to. And so it showed us that it's a good thing we were in a test bay, or somebody would have been hurt.
Mm-hmm. We've seen pressure vessels come apart under hydrostatic shock. It's quite impressive.
That's true.
Beyond Sargent, what were some of your early spaceflight experiences?
Well, in developing Sargent, we first fired, and I was responsible for testing a 6-inch design of the Sargent before we actually went to the big Sargent 31-inch diameter case, which was the largest solid rocket motor made in the world. And with those 6-inch designs, we determined that everything was going quite well in that regard, and it turned out that the 6-inch design was what was used to put up the first satellite for the U.S.
The Explorer 1.
The Explorer 1. And we were very fortunate that those things were designed and worked quite well, and the testing all turned out to do exactly what it said it would do.
That's pretty significant. That's right on the doorstep of space.
It was fun.
Was there any structure at this time that would, by today's standards, be considered to be mission assurance, such as safety, quality assurance, reliability, etc.?
I don't recall any quality assurance reliability, and I know there was no safety relative to our particular end of things, and every engineer was expected to take care of his own stuff. He's supposed to be safe with it and that type of thing. And when he studied and made a design, he was supposed to have safety factors associated with it, and nobody told us what safety factors to have, what you should have. We knew that if you were building a large structure for holding a house, holding a building, something of this sort, safety factor of 4 was being used, but we couldn't do that in space because of the lightweight designs. It needed something else. And so every engineer was responsible for assuring that his stuff was going to work well with proper safety factor.
From your perspective, how were those areas evolved at JPL, meaning the quality assurance, reliability, and safety, and in particular getting into the system safety
There's only one
aspect?
that I can tell you about, and that is my particular area, because I was had my nose to the grindstone on designs of rocket motors, and then motor cases and nozzles and jet vanes, and those are all different kinds of designs. Anyway, I was related so much to that, I didn't know what was evolving in the other areas. However, in safety, in 1963, actually I think it was 62, that they started getting concerned about that, because the people that were making the Surveyor Hughes aircraft were responsible for making it correctly, and when they did their first design analysis of what they were doing, they found out there were a lot of areas that were lacking, and they said, gee, we should have had somebody looking at these areas, and they decided that at that time they needed a safety person. So they came to, I don't know how many other people, but they came to me and asked if I would do that, and I said, no, I will not do that, because safety people have no recognition, and nobody's happy with them. Everything you do, nothing but give them bad news when our safety person gets there. And I told them some other names that they could go to at JPL and ask, and I thought I'd gotten that monkey off my back. And about 6 months later, Jack James came back and said, we need you. And I said, well, it's going to cost you. So we did a number of things, and that is, first he says, you're going to work for Giberson, who was in charge of that project. And I said, nope, I'm not. I said, you can see that if I work for the project manager, and all I do is give the project manager bad news, what's he going to give me when it comes to raise time? Bad news. So I said, I will not do that. I have to work for some other person up the ladder that has control over he and myself. And so they decided at that time then that I would go to work for the division manager for projects, and that was Bob Parks. So I went to work for Bob Parks as a safety person, primarily working at that time on the surveyor.
That's quite a start.
Well,
Good thinking at the time.
it's the only way it's acceptable.
I agree with that. As you move forward from that point and develop the System Safety Office, tell us a little bit about the early days and maybe who you brought in on your team and how that interacted with the projects.
Well, we had a number of projects going on, and they, well, I should back up just a little bit. At first, surveyor was the only big project, and so the others were coming along in study stages and that type of thing. They didn't think they needed any safety person at that point. So the only thing I did was surveyor. However, as the other projects came along and started getting on there, I told my boss, Bob Parks, that, hey, we need somebody watching these other projects, because from the beginning you have to build safety into the plans. And therefore it's not a proper thing that you design everything without considering safety in a proper way. At that point, there were, like I say, several projects, and so for another project I brought in Bill Woods. In fact, there were a couple of people that came to work very shortly. I was working for John Small, pardon me, and I was not working for John Small. The person working for John Small, he wanted to come over and to work for me, and he gave me a person whose name escapes me at the moment, but it was, well, it did escape me because he was not of value. And I turned down that. After working with him a little bit, I turned that down. Anyway, then as we moved along, there were a couple of people that happened to, and then Mr. Woods came along and was a very good engineer to work in safety. And he started working with me, and so we kind of alternated projects as we went along, as these projects kept developing. Kind of an interesting part of this was that as we went to the Cape to fire the motors off, the people at the Cape said, look, we've got safety covered. We don't need him here. And that came from the guy who was in charge of Cape operations. And he had just gone up, well, as he was going up to 180, talked to Jack James. He says, you're not going to the Cape. I had just put in for the money to go. And I said, okay, that's fine. As he came back down, I happened to be going the other direction. He says, win a few, lose a few, we'll see you in Florida. So we went down as part of their team, and they did have a safety organization down there, but frankly, I'll be bragging a little bit, I guess, but good thing they sent us down, because their organization was just not sufficient. They were not hard-nosed. And believe you me, they found out that I was. So we went to Florida, and we had a number of things going on there, and one of them was working with the people at Berkeley. One of the projects, one of the instruments, was a detector that was going to the moon to jump down on the thing and do some radiation was using the wrong kind of a material, and I objected to that. And at first they said, okay, we'll change that. The answer came when we got to Florida. I found that they had not changed it out, and they were using very toxic stuff, which was hydrogen, instead of the neon, which they were expected to use. And they had a high-pressure tank full of hydrogen, 6,000 psi. And when I asked them, well, what's the safety factor in your tank? They said, we don't know. They didn't build any safety factor. And I said, well, we're going to build a safety factor to this. First place, I have to back up here a little bit, because I found that out early before the design was totally completed, and I found out that the hydrogen reacted with the stainless steel that they were using, which would scissor the molecules and either open up and leak out or burst or whatever. As a result, I said, you're not going to use that material, you need to use something else. I looked around the country and found out at Rensselaer that there was a testing going on, and their first reaction was, we're not going to change it. So I had Rensselaer tell me what their testing was doing, and it turned out that the hydrogen, like I said, would scissor the materials that they were using. And I said, you can't use it. Well, instead of finding someone to really, I wanted them to go to Rensselaer, and they wouldn't do that. They went up here to Tiffany in Boeing up in Seattle and said, he's going to do that study for us. So he did, and he came out with a material which was very thick, which he said was fine. And I said, okay, let's test it. And the more we tested, the more we found out it didn't work. It blew up. So as a result of that, then we had to finally go to another testing method where they proved that the material that was going to be used would in fact stand the hydrogen pressures, and they found one. So from there we went to building this out of a proper material. Then I found out that they were putting 6,000 psi hydrogen in it with no safety factor, and I told them they would have a safety factor, and they said, we can't do that. I said, yes you can. You can lower the pressure. Instead of 6,000 psi, put in 4,000 psi. Again, they got very upset with me. In fact, the person that got upset with me was the manager of that particular project, and says, that's the way you feel about it, we won't fly. Well, I had a good engineer, a good manager at that time, who happened to be Kasani, and he had faith in me after he had seen a number of things that had occurred, and he said, okay, if you don't want to fly, that's your problem. They changed their mind after a little bit, and they decided to fly. And it turned out that the material went up there, it did work, it did the things that they wanted, and there's a whole story that goes with the engineer's assessment as to what they had found on the moon, because he made a prediction of what was there, and he was wrong. So, so it
made him a good materials
That's
engineer,
right. He had a hard time with that.
Well, that's a beautiful example of the clout that you had with safety in the earlier projects.
Well, the point I'm trying to make is that the clout came only from doing things correctly,
Right.
and making sure of what you know that is right and what's known by experiment or chemical analysis. And that
Base
type
it
of
on
thing.
fact.
Base it on fact, not on belief.
Now, how did you go about developing those kinds of things into requirements that were then formally placed on the projects?
Well, we had to do something, and because they didn't have any, any particular gauges to go by to actually do their testing, do their designs to, I should say. So you couldn't use the 4 required for structural type things, so I went down the line and personally did a little bit of testing and decided the best we could do was to ask them for a safety factor of 2, and for a while that worked. And the the stuff was light enough it would be able to fly, and it was strong enough that it was going to be safe. But later on, I took a class about fracture mechanics, and this kind of shook up the whole JPL and NASA and a few other people, because I took this class and determined that we could determine the safety factor by using chemical analysis and by determining what safety factors we were going to have, and as a result of that, we reduced the safety factor to 1.35, and that made everybody happy at that reduction, but they weren't sure about how to do the testing for it. Mm-hmm. And that's when we started designing things to test to the fracture mechanics end of things. And that's how fracture mechanics got into it. As far as I know, I don't know whether anybody else did it or not, but JPL was responsible for the fracture mechanics, and selling the fracture mechanics to NASA at the launch sites was a real problem. They did not want to believe it, and I said, that's what we're going with, and until you prove us wrong, well, that's the way it will be. And they finally accepted it. And everything's done with fracture mechanics now.
I started working a little bit with Joe Lewis on fracture mechanics in 1968, so was that about the same era?
Same era, we were just a little ahead of that we were getting into it.
Okay. Were there other NASA centers or even commercial companies that you were aware of that were developing a system safety approach and department like we were, or was JPL unique in this?
Well, JPL started out being unique in that regard. However, everybody decided to get on board, particularly the NASA centers. And therefore, we had some meetings with management, with Jeff Robillard and myself, about what we were doing and what the value of it was. And I made a presentation to NASA relative to what needed to be done as far as safety was concerned on flight projects. And so they got on board, and everybody started getting their flight project managers. It turned out that was kind of a unique thing, and so much as these people came on board, they weren't aware of a lot of the stuff, so I gave them a lecture as well as a brochure of how we were doing our fracture mechanics and let them learn from that. Of course, all of them came in saying, well, I'm going to develop my own, and so everybody had a little different idea of what they wanted to do. And we fought over this for long periods of time.
Well, how did that safety function, system safety function, become more gelled, more formalized as a recognized part of the project and the agency or just center?
Well, the agency started recognizing that there was a need here, in particular when they saw what we were doing on our first projects. And therefore, when they decided to have those people and appointed a safety man for each project, some of them did them one way, some did the other, and I say one way. Some of them used their safety people who are building safety people and say part of their job will be fracture control on spacecraft. And that really wasn't working too well because, like I say, structures requires a lot of different materials evaluation than what spacecraft does. And as a result, they finally came around. I made, like I say, several presentations to NASA headquarters and to the managers that were getting ready to do this fracture mechanics stuff, or I should say this fracture control of spacecraft. Now, a big part of that, if you recall, Bob Bamford was a materials man. He was a physicist that was working at JPL, and as far as stresses were concerned, he could make analyses on the stresses of different types, and he and I worked very closely to develop what was needed as far as spacecraft was concerned, the types of structures you could have that would put the least stress on materials. Acceptable stress is what I should say, not the least, but the acceptable stress in the materials.
As the safety function, system safety function became more formalized, when was an office actually named System Safety Office
Well,
or Flight Project Safety?
that's kind of a hard one in so much as when we first appointed me to work for Bob Parks, it was just called the Project Safety Office. And then they decided that the PSO that I used was another part of the laboratory, meaning something else, and they wanted to change it, and so I said, okay, let's make it the System Safety Office, and then they said, no, that was already taken for somebody else, and so we just kind of worked our way through this, and finally just decided to end up with actually for a while it was Project System Safety Office. And that's because we could use the initials PSSO and nobody complained.
Found one that worked.
Right.
So you were manager of the formal JPL System Safety Office until when?
Well, until, I guess until Brea took over. Okay. I'm having a little hard time with my memory here because at one time we actually had the office, well, and for 20 years, I should say, the office worked under Bob Parks. And that's where I wanted it, and I argued every time they wanted to put it out somewhere else. But a lot of other places were having the reliability and product assurance office and putting the system safety office together, and the people in headquarters did this and wanted us to follow suit. And I heartily objected because they often wanted the reliability. A lot of people said reliability and safety, all is the same thing. It's if you're reliable, you're safe. Not necessarily true.
It's not true.
And therefore I argued heartily for not doing that, but finally when Bob Parks retired, they put us together under Shipley in the reliability office and product assurance. So then we became part of that, but we still maintained our own entity of being a system safety to look at things differently. Look at the safety product, not is it going to be reliable, because sometimes being very reliable was very unsafe.
Exactly right. Reliability guarantees it's going to work.
Yes, and sometimes at the wrong time.
Right. What personal accomplishments over your career are you most proud of?
Well, I had 3 patents going, but this was before I got into the system safety office. This was when I was developing propellants. And we had to have a sterilizable propellant to land on the moon. As a result, I put 3 formulations together to sterilize and make sure we didn't carry any bugs to the moon. And one of them was a chemical type thing which we used to sterilize the entire propellant as we poured it into the solid propellant case. Another one was we used a type of propellant that you could heat to the point of killing the bugs in the thing. And the third part of that was the silicone that I had used to be able to do that, to heat it and contain the fluorine, fluoric oxide, which was a sterilant, that it would kill the bugs. Developed that to go on to cover instruments, that type of thing, which I said would be good for the field use for armies and this type of thing, because you could just rip it off and you'd know that whatever you wanted to use in the field, whether it was to cut someone open or to heal a wound or sew up somebody, it was sterile at the time. So had a lot of people interested in that, but nobody wanted to develop it. They wanted me to do all the developing to put it into a process. And I didn't do that. JPL didn't let me do that.
But they're still on the record, and they're still your accomplishments.
There you go.
You've seen a lot of changes in system safety and the way we approach mission assurance over the years, up to the point in particular that you retired. Just for fun, where do you think it's going? What do you think will happen to mission assurance and system safety in the future?
Well, all of those things always have a big pressure on them because they're trying to make things cheaper. And the first place they think they can save money is in those areas, mission assurance or system safety, this type of thing, and try to go back there. I think it's going to be a battle all the time, and I believe it should never happen that it would be given up, that you should not have a time when there's not someone special outside the realm of the project to really look at the assurance of the project. And the reason is, too many people in the project are very, very biased. And I'll give you a point here. We were having this thing built at Boeing again. I've forgotten what project it was, but they wanted to pick up this entire project of spacecraft and to put it over into a cylinder to be tested. They insisted that our people not go there because Boeing, quote, has its own safety people, therefore they don't need anybody else there. And of course, if you recall history, they lifted the thing up and it tipped over upside down, which was against the rules in the book that we had given them to live by, and they didn't live by it.
Very famous incident.
That's right. And as a result, they immediately came and said, all your fault. I said, look, you're not going to blame this on me. I immediately wrote a memorandum to the director with a copy to my boss saying that this was not our fault. We told you to do it in a different way, but nobody read the manual. And therefore, if you had sent us up there, we would have had our manual out and it would not have happened. See, that's one of the problems with being safety, R&QA, and all those types of things. You show that you're needed because of accidents. When it turns out you have an accident and said, my gosh, if we had a safety guy there, it wouldn't have happened. Because as long as the safety guy is doing things right, it doesn't happen. Therefore, they get a feeling that they don't need you because we haven't had any problems like that. And the reason is we go by and save them before the project really understands the need for us. As a result, they think that they're doing everything great and they don't need us.
When we do a good job,
We're
it's
never
not obvious we're needed.
That's right. And safety never gives any good news except to say, see, it worked. And otherwise, pardon me, if it doesn't work, that's when they'll say, gee, we wish we had you.
We get that almost every day.
That's true, I'm sure.
With all of this great success in your career, tell us a little bit about your support group, commonly called the family. You've got a son who's done great things at JPL, and you have a grandson who's working at JPL.
And doing great things.
And doing
I think he's a great guy. But thanks for asking. It turns out that it was very hard on my family because I worked long hours, and my wife said I was married to JPL instead of her at times. And we didn't take time off as often as we could have. In fact, I lost a lot of days that I could have taken because we were flying down at the Cape and that type of thing. But she let that go and was very happy she stayed, and everything has gone well. And I'll have to mention that when my son graduated from UCSD, he graduated magna cum laude in science. He had 3 degrees, one in science, one in education, and then one in minor in physics. He'd started there in physics because that's what I thought he ought to do, and he's trying to do what I wanted him to. He decided to change it. Anyway, bottom line was, I said, hey, go apply at JPL. He said, no, 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 I'm going to Alaska and make some big money. You're going to go up there and sell real estate. Well, he went up there for about 8 months, and the people that he was working with weren't that honest. He found out that they didn't do things correctly, so he came back home to do some other things, not work for JPL. And then one day he came home and says, hey, guess what? I work for JPL.
That's a bit of a surprise.
Yes. I said, hey, that's the greatest move you've made. So, because I had enjoyed working at JPL, the work was fun because it was always challenging. And if anybody likes a challenge, that's the place to be. If you don't want to be challenged, don't go to JPL. But anyway, that's the way that worked. My grandson is a very similar type thing. When he graduated, he went to work for a sound stage. He had an uncle that was over there and worked for him, so he was a page or something of this sort. He ran errands. He was an errand boy for them for a while. This type of thing. Got very bored with that. Then started up another company that 4 other people said, we'd like you to work at this company, which was doing credit card type things. Anyway, he got involved with that. He was running it well, but they wouldn't support him in getting more business, and he couldn't do all those things. So he came home one day and said, guess where I work? And he works at JPL. They had to put 3 people in to replace him in the company that he left, and finally the company folded. But anyway, that's the family.
That's a pretty good legacy, too.
That's
to have that many people follow you into JPL. What do you do for hobbies?
Hobbies?
I know you wield a pretty mean tennis racket.
I enjoy playing tennis. I play twice a week, every week. It's not raining, and this type of thing, unless I'm out of town. The other hobby is to go traveling to see how the other half lives, or pardon me, see how other people live in different countries. And we've been throughout a great amount of the world, and the place that I'd like to go yet is Africa. And I've been to Australia, but that's, I should say New Zealand is a place I'd go back to. My wife doesn't necessarily want to, but so I guess it'll be a while before we get back there. The other place, I enjoyed China very much, and it was a very interesting experience in China, and I would do that again, but my wife doesn't want to go.
Well, it's been a pleasure chatting with you right now. I brought a few of the System Safety Office folks along, and we'd like to open up the discussion a little bit and
Very good.
have them join us and ask you a few questions that have come to their mind as we've developed this little bit of history.
Okay, that'd be very fine. I'll do what I can for them.
Okay, Monty, we've got about half of the System Safety Office here. Each of them can introduce themselves. I think they've all got a favorite question to ask you based on the tremendous legacy that you've just poured out in front of the camera here for us to enjoy. I know I've been with you since 1987, and even prior to that, as you mentioned, some heated discussions, shall we say, with folks at the Cape. I remember one that we had going toe-to-toe, you and me, sometime before you invited me into the System Safety Office. And as I remember when I first came to interview with you, you reflected on that and said, that's the kind of hard-nosed son of a gun that I want working for me.
That's what it takes.
Well, anyway, as I say, we're a staff of about 13 now. We have a lot more functions than you would ever dream of that are part of the System Safety Office, but as part of the growing reaches of system safety and applying system safety to many other aspects of safety at the laboratory. So we're rather proud of that.
Good. Very good.
Some of those folks are here representing some of those new disciplines, fire protection, for instance, with Greg. Anyway, I'd like to open it up, and I know some of the folks have some questions they'd like to go ahead and ask you. And some of them may have a little bit
You're
of
gonna-
color attached, and that's
You're
fine.
going to have them introduce themselves first, or?
I was thinking one at a time.
Oh, okay.
So that forces each one to have a question.
There you go.
Yeah. Well, Monty, I'm Carrie Vonsuti, a system safety engineer in the office. I was wondering when you, during your interview, you know, after JPL had that formal system safety office, how many are in the office? How many systems engineers were in the formal office? Not the time when you know, started with the project, but the formal system safety office.
Well, the maximum I think that we had whenever I was running around doing many projects was 7. I think there were 7 engineers. At times we had a couple people that were, what I want to say, working on other types of projects in our office, and we had people sent to our office for different reasons, and some of them didn't work out well, and we had to. But I think the main working group that we had, as far as engineers are concerned, not county secretaries, was about 7, because that was about running about 10 or 12 projects, depending on what was happening, and depending on what year it was.
Some instruments, some spacecraft,
Right. Now,
including a lot of shuttle work.
yeah, let me make a point relative to instruments. They used to say, "Hey, you don't belong in doing any instruments," and we found out that the materials, what I want to say, the instruments all had very sensitive diodes or other things in them that would be blown out just by the amount of material charge is
ESD.
gathered on a body, and we worked quite a while on that. And this was another time people did not believe us that we wanted to do the ESD type thing, and they did not want us doing that until who was it? Up in San Francisco, and we were buying these ESD from them, and 80% of them were blown out when they got here, and they said, were they blown out back there, or were they blown out at JPL? And we assured them they were blown out back there, because we took all the precautions at JPL to see everybody was grounded and before they ever touched these things. And we had a hard time proving that to be the case, but we finally made the case, and then everybody started getting on the bandwagon.
Well, now that's, of course, a very, very fundamental discipline in handling sensitive parts, not just the electronic parts,
Right.
but detectors, which, of course, are very high-density electronics.
Right.
Very excellent question. Anybody else have a question?
Yeah, I've got one. Ben Lucas. I came from the Air Force side, and your name was mentioned over there quite a bit on occasion. So I was wondering what kind of interface you had with them.
How was it mentioned?
I was afraid you were going to ask that. No, actually, it was brought up very nicely is that you were considered one of the fathers of it too, as far as the true system safety from a systems engineering standpoint.
Well,
That's
working,
what was used as a background for during the courses and everything that we had.
right. Well, working with the Air Force was a good thing to do, because there were a lot of people that were, some of which were very interested. Other people were interested in kind of shutting us down because we're costing them money. But they were always looking to money aspects. But working with the Air Force, we had a number of projects that were going, and they actually did well in listening to what we needed to assure that we were going to have a good product. And therefore, they were a good bunch to work with.
Karen Moran, System Safety. What year did you retire, and how many years had you been at JPL?
Okay, I started at JPL 1955, October the 3rd, 1955. I was going to stay there 3 years, but it got to be so interesting I could not leave, and I didn't leave until I'd been there 38 and a half years. That was 1994, March the 11th, I believe was the number.
94.
Yeah, so it was 38 and a half years of the best time of my life, except for a few little things here and there that people and I did not agree on. So.
Well, you've got a couple of people here that were with you for quite a number of years. I was with you since 1987.
Right.
But actually, Karen was in the office when I joined you.
Yeah, well, almost. I started in 1988, January 1988. I'm Karen LaRue, and at that time, I know they'd been told that this was had only been the system safety office as it was at that time, where it was a separate section and stuff had just started that fiscal year, I believe, the fiscal year of '88. And what always tickled me was that when Monty told me when he started, I thought that was the year I was born.
I wasn't even born.
Yes.
I wasn't mentioning that because I wasn't born.
But
Okay,
which
yeah,
really
question.
made you feel old. I'm sorry, Lonnie. But you always had the most interesting stories to talk about past history and lessons learned and stuff like that. And I remember one story you had told me about when you were doing some testing. I believe it was at White Sands with a corporal, and you had a run-in with a base commander. I wonder if you can remember that one.
Yes, I remember very well, but it wasn't at White Sands that I had the one with the commander, and that was at Huntsville, Alabama. And we were down there with the sergeant motor. It was classified, totally classified to look at, even when it was, except for the outside, when it was loaded. And the commander, named Colonel Chatfield, came in and said, "I want to bring this busload of people down to look at your engine." And I said, do they all have their classifications? As soon as I look at the classifications, you can go down. And he says, "That's not important." Says, "We're going down." I said, "It's up to that guard right there to stop you if you don't have your classification." Turned out nobody got off the bus except Colonel Chatfield. Then I received in the mail from New Orleans headlines which said, "Montgomery chastised Chatfield and lived."
Is that in your scrapbook?
Yes.
And then what did Dr. Pickering?
Oh, well, yes. When I had seen my reputation had preceded me to the laboratory, when I came into the gate, the guard says, "Dr. Pickering wants to see you." I thought, uh-oh, back to the farm.
At that time, Dr. Pickering was the director of the lab.
Right. He was the director of lab when I went to work. And two other people stopped me on the way to see Dr. Pickering because they said, "I want to hear the story before we started." And I told them exactly that. And I said, then I did carry it a little further, and that is I did tell Chatfield, I said, "If you violate this, I'll have to report you." And he didn't like that too well. And each one of them understood, I think, and when I got to Pickering, he says, "Well, you did what you were supposed to, but let's forget it from here." I said, "Okay, since you're my boss, I have no problem. You're going to let me live?" Anyway, that was one of the run-ins I had, and I guess that's when they found out I was very hard-nosed about
It may
following
be
the
important
rules.
to point out that the corporal development, corporal or sergeant?
Sergeant.
The sergeant was being developed for the U.S. Army at the time, so that's why it was so highly secret.
That's right. It was a secret, and the what do I want to say, the material itself that was made of the solid was secretly classified, and that's what they were trying to protect. I helped them.
Okay, who
Monty,
else got a
I'm
question?
John Gillison, and I'm the newest addition to the System Safety Program Office. And from 1955 to 94, a lot of things happened. I'm sure you've seen a lot of projects. Was there a favorite one you had that you worked on, or one you had that got the most fun out of, or satisfaction?
Well, the ones that I got the most satisfaction out of those were the ones that I had a role in protecting. And in that regard, the surveyor was one of them. The, gosh, what was the next one? There was another one that we were flying. They were flying bad tanks on. I can't remember what the name of it was. It was headed for Mars. And the thing was, we changed the tank material and made sure that it was correct which saved it from. I told him you wouldn't have been very happy if it had blown up halfway between here and Mars, because you'd say, "Oh, well, that a meteorite hit us."
I think that involved hydrogen and
Yes,
the infrared instrument,
the infrared instrument again. That's right.
changing to titanium and hydrogen creating titanium hydride.
Yeah, that was that story that I had told a little earlier as part of that, and but it took these kinds
Same-
of
same
arguments.
PI.
Same PI. That's right. And you had to. Oh, here's a very minor thing, but when they got down to the Cape, one of the rules was that you couldn't wear non-toed shoe wear,
Open-toed shoes.
open-toed shoe wear, because there were too many things for you to ruin your toes on, and all they're doing is trying to protect people. But the people from Berkeley all wore sandals for one day, and we arrested them all and took the sandals away.
So they were barefoot.
They had to go buy some shoes.
We still have experiences working with the universities that come from a different world.
They do that.
Monty,
Okay.
I'm Greg Ellers. I work fire and life safety here for Jim. I've been with them, with the system safety people now for about close to 4 years, coming on 4 years. My question for you is on the personal side. Notwithstanding a good education and good experience background, what would you say are the two most valuable characteristics or personality traits a system safety engineer should have?
That's the easy one. First place, he's got to know what he's talking about. Understand, if it's chemical, mechanical, or whatever it is, what the real problem is, and it is a real problem, not just a supposed problem. In other words, he has to prove himself. And secondly, he has to be so hard-nosed, he doesn't let people talk him out of it. You can't go along and say, well, okay, I'll back off a little bit, and this type of thing. Not that I wasn't, what I want to say, easy relative to trying to get projects off the ground, because I was as interested in everybody, all the projects flying, as anyone else. It was just that we had to make sure that when they did fly, that they flew in a correctly built, I'll put it that way.
Part of the team, but just a different perspective. We want to see it get launched, so
Right.
the rest of the team can enjoy the mission.
Exactly. And the thing that they used to not understand is that they said, when your only problem here is ground stuff. And I said, no. Our problem is seeing this thing fly as properly and safely. And then they'd say, well, just so it doesn't hurt people. I said, no. It's so the project itself works properly, as well as not hurting people. Of course, hurting people is the first thing that you need to protect against. But in doing that, you're making sure that the project itself is built in such a way it won't hurt people. I'll give you an example. We had the problems with the surveyors. The thing that, when I came on to the project, that stuck out in my mind, I was just new into this thing. It turned out that they had shock absorbers that were built with 1800 psi in the barrel, and they had, evades me now, but a very, very small, thin tank that was holding this.
The
And
cylinder.
The cylinder was holding 1800 psi, and a small scratch on the cylinder would reduce the capability of that cylinder by 30%. Now, all this I determined by going to people that had run these types of tests, and we ran some of our own. And so I told my boss, and then Jack James, who was doing part of that, he was essentially my boss at that time. Parks was working on something else. That this thing, if you hit it on the edge of the table, it'll blow up. And he said, good gosh, we just passed that thing around the conference room, and anybody could have dropped it on the edge of the table. And I said, probably wouldn't kill you, just put all your eyes out. But
You said it had a catastrophic failure. It exploded with shrapnel, didn't you?
right. Now,
Yes, we have that photograph.
good, good. You see, I insisted, I asked them if they had been proof tested. And they said, what's that? I said, these things should have been tested beyond their capabilities so that you know they'd be able to hold this pressure. And they had not proof tested them, so I insisted that they reduce the pressure out of them, go in and then pressurize them back. And when this one exploded, after they had reduced the pressure out and started back up, it only got about 75% of the pressure, and it blew. And they finally saw the light. Only can you prove to them something like that before they'll see the light. Anyway, that proved to them that we weren't just whistling Dixie. We were
And
Whatever.
the epilogue to that one was that the first lunar surveyor, it was too late to replace them.
That's right.
And so it went to the moon. You told me in your story and landed safely, but Apollo came along.
Right. And when the Apollo people got up there, they decided they were going to bring back one of these pieces of equipment that was right next to where the pressurized part was. And I had the opportunity to talk to the astronauts, and I said, don't touch it. And that we don't know what's happened to it since it's been on the moon, how long it's been, whether it's just getting ready to blow, or maybe the pressure has leaked out and it's not pressurized any longer. We don't know. But you may blow holes in your space suit if you touch it. So they were able to bring back a camera, which they were cut off right above that, and bring it back with them. But they had the knowledge that they were running a risk. And like you say, we put, all the time that people were around those things, we put shelters on them so that they wouldn't blow, or if they did blow, they wouldn't hurt people, but so that you couldn't get to them to hit them or hammer them or anything of that sort. And that was
very fragile.
Very fragile. And then they changed to a different material, and the last ones had a proper material on them.
Well, it has certainly been an enlightening pleasure to have you here with us today, and we appreciate your time and coming over and chatting with us. In getting ready to close it off here, what do you have in a one-sentence word of advice?
Caution. In everything. It's been a pleasure talking to you and reminiscing. It does me good to remember the old days and how they went. Now I told you the good parts.
The other parts come over a beer.
That's right. We had our troubles all the time. You have to expect those, and you have to plan on how you're going to confront them. The main thing is to have a boss that will believe you. And that was what I ended up with. Bob Parks and Jack James were the two best bosses at JPL. And I had the opportunity to show Pickering around a few times and talk to him about some of the things. In fact, he came when we went out to Edwards Air Force Base. He came asking me to show him around, and I was flattered by that. Not that I knew as much as everybody else, but I knew I could tell him most of it. Anyway, it's been a real good tour at JPL. I hope you all find it as good as I did. You can't let people dictate what you should or should not do safety-wise, because you have to know what you need to do. That's the best advice I can give you.
Monty Montgomery, thank you.